Assalamu alaikum. This is chemistry 11th, and our today's lecture is about electron gain enthalpy, delta EGH, that is electron gain enthalpy. Now, as far as this electron gain enthalpy is concerned, we have seen in ionization enthalpy. We have seen in ionization enthalpy that it is the energy that is required to change a neutral gaseous atom into its cation, and its value is always positive, because in this case energy is required. Now, as far as this electron gain enthalpy is concerned, if the atom is to gain an electron from an outside atom to form an anion, in that case the energy is lost because of attraction between the nucleus of the atom and the incoming electron. So electron this gain enthalpy is it has got a negative value. It can be, now we can define it as like this electron gain enthalpy, we define it like this the change it is the change in enthalpy when a neutral gaseous atom gains an electron to form a monovalent anion, also in gaseous state. Now you can see here, this is an atom in gaseous state. Upon gaining one electron, it changes into an anion, and there is an attraction between the incoming electron and the atom, so energy is lost. So this delta Eg, that is electron gain enthalpy, it has got a negative value. Now, as far as oxygen atom is concerned, when oxygen atom gains an electron, it forms an anion. This is O minus, and electron gain enthalpy in this case is minus 141 kilojoules per mole. That is, it has got a negative value because energy is lost. Now, it is, as I have told you, that it is value is negative because energy is released in attraction process when an atom gains an electron. Now, in case of atoms with symmetrical electronic configuration, like we see in case of noble gases or in case of alkaline earth metals, the atoms have no urge. They do not need to gain extra electron, and energy is supplied in such a cases. So because of their symmetrical configuration, we see their energy is there needed, or is needed because in order to gain an electron. Thus, electron gain enthalpy would be positive in such cases, that is, atoms which have got a symmetrical electronic configuration. This is because energy is needed to overcome the repulsion between the anion, between the anion. This is, you can see anion, how when it gains an electron, it changes into divalent anion, and in this case we see electron gain enthalpy, it has got a positive value because there is now a repulsion between this anion and the incoming electron. Now, similarly, in case of, we have got this is neon, it has got a symmetrical configuration. We see all it is these occupied orbitals, they are filled. So when it gains an electron, it changes into neon, this is anion, and delta this electron gain enthalpy, it has got a positive value. You can see here it is 116 kilojoules per mole. Similarly, in case of magnesium, we have got a 2s orbital. It has got two electrons in its 3s orbital. So again we see energy is needed here. That is, electron gain enthalpy has got a positive value. It is plus 67 and this kilojoules per mole. Now, as far as its units are concerned, the units of this electron gain enthalpy, they are same as that of ionization enthalpy, that is kilojoules per mole. Now we have got this successive electron gain enthalpy. Now, as far as this successive gain successive electron gain enthalpy is concerned, as we see in case of this ionization enthalpy, we see electrons are lost in succession, that is, one after the another. In a similar way, we see here that electrons are also accepted, or their electrons are gained in succession, that is, one after the another. Now, in case an anion is to gain and another electron. In this case, we need energy to overcome repulsion between anion and the electron. So delta G, so electron gain enthalpy in this case, it would be it has got a positive value, because this is when an anion is to gain an electron. I have shown here, this is the anion, this is oxygen. When gain is electron, this delta G, it has got a positive value. Now there are the factors which affect this electron gain enthalpy. One of the factors, that is atomic size. Now as the size of the atom increases, the distance between the nucleus and the incoming electron also increases, and it experiences and the incoming electron, it experiences less attraction towards the nucleus of the atom. Therefore, electron gain enthalpy, it becomes less negative. That is, its value becomes less down the group, because as we move down the group, we see that the size of the atom increases with the increase in the number of, with the addition of new shells, and the valence, electrons, they move further. So the incoming electron, if the incoming electron is to approach such an atom with large size, then in that case we see it will experience a least attraction from the nucleus. So automatically, or obviously, we can say the electron gain enthalpy will have less negative value. Then we have got another factor, that is nuclear charge. Now, the increase in the nuclear charge, with the increase in the nuclear charge, the force of attraction between the nucleus and the incoming electron also increases. So is the value of value of electron gain enthalpy. That is electron gain enthalpy becomes more negative with increase in the nuclear charge. This is the second factor. Third factor is, we have got this symmetry of electronic configuration. The atoms with symmetrical electronic configuration, that is having filled or all half filled orbitals, as we see in case of these noble gases, or as we see in case of nitrogen, where we have got all half filled orbitals. They have got symmetrical this electronic configuration. So such atoms, they do not have any urge to take up an extra electron, to take up an extra electron, because of their symmetrical configuration. So one, if they will accept an electron, this electronic configuration, it will become unsymmetrical, rather it will become less stable. They will become less stable. Now in case if these are still made to accept the electrons, then energy will be needed, and electron gain enthalpy will have a positive value, as I have given you the example of these noble gases, which have got this positive value of this electron gain enthalpy. So these are the various factors which affect this electron gain enthalpy. Now, as far as variation of this electron gain enthalpy across the period, or down the group, is concerned, now as we see across the period, we see there is an increase in the positive charge of the nucleus, because electrons are added in the same shell. So electron gain enthalpy, it will increase, whereas as we descend a group, or as we move down the group, this size of the atom increases, and electron gain enthalpy, it also decreases. So this is for electron gain enthalpy. Thank you very much.